All right, Math 103, 5.6, scientific notation. So with scientific notation, we are going to be able to write very large numbers or very small numbers with powers of 10. So you are going to express your scientific notation in this format. And so I tell students that they have to fill in the blanks. Blank times 10 to the blank. And those time 10 will always be part. Now be very careful when you do this in my math lab. This is not the letter X, okay? So use the multiplication symbol on the math palette in my math lab, okay? So you have a number that's going to go here. That number we call A, and we have an exponent that's going to go here, and that number we call R. Now, A has a restriction on it. It has to be greater than or equal to 1, but it has to be less than 10. And then R is going to be an exponent. It's either going to be a positive exponent or a negative exponent. So there's some procedures here that you guys can read through. The way that I look at it like this is I give you some rules to kind of give you guidelines about the exponent. Let me make a note here, okay? So let's go up here. If the original number is greater than 10, then R will be positive, okay? If the original number is less than 1, then R will be negative. And it'll be very clear. I mean, it's going to be, 17 billion or 0.00000038. I mean, it's going to be very clear that it is definitely going to be greater than 10, and it's definitely going to be clear that it's going to be a very small number, less than 1, okay? So when you have a problem like this, first thing that you have to do is locate. In this example, you have to locate the decimal point. So if you don't see it, it's at the end of the number. Then you will write blank times 10 to the blank. This number right here, 5,800,000, is greater than 10, so the exponent will be positive, okay? Now, I need to move that decimal point so that I have one number in front of the decimal point, okay? So I'm going to move that decimal point between the 5 and the 8. So that makes my A 5.8. These zeros will drop off. To get my exponent, I have to actually count how many places I moved the decimal point. 1, 2, 3, 4, 5, 6. So my answer would be 5.8 times 10 to the 6. You have to have times 10 to some power, okay? You can't leave that off. That is not the same as 5.8 to the 6, and that's what I see all the time. It has to be multiplied by 10 to that certain power, okay? All right, so the next one, we've got blank times 10 to the blank. Again, this is a very large number. It is greater than 10, so your exponent is going to be positive. If you don't see the decimal point, it's at the end, and you want to move it so you have one number that's not a 0 in front of the decimal point. So you're going to move it all the way to between the 3 and the 1. So 3.106. The only numbers that drop off are what we call trailing zeros. That 0 between the 1 and the 6 is what we call significant. So you cannot drop that off. And then I count how many places did I move it. 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is 8, okay? All right, we've got another one that's a very large number. Blank times 10 to the blank. Here's my decimal point. I'm going to move it so that it's between the 7 and the 2. So 7.263. You may not leave off any of those digits. The only digits that drop off are the trailing zeros. Now you count 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Going the opposite direction, we now have very, very small numbers. We see the decimal point. This number is less than 1, so the exponent is now negative, okay? So blank times 10 to the blank. I'm going to put my negative sign up with the exponent. And then I want to move that decimal point so that there is one number that's not a 0 in front of it. So I'm going to take that decimal point and move it between the ones. So the front zeros now drop off, and I have 1.1. And then I count how many places did I move it. 1, 2, 3. Whoops, that's not what I want to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so my exponent is negative 12. All right, blank times 10 to the blank. Move it so there is one number in front of the decimal point that is not a 0. So 4.92. It is a negative exponent, and then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 10 would be my exponent. So that's putting very large numbers and very small numbers into scientific notation. Now we're going to reverse the process. We're going to go from scientific notation to what we call decimal form. I think this is a lot easier because if you think of a number line, we've got 0 in the middle, we've got positive numbers to the right, and we've got negative numbers to the left. So if we have a positive exponent, we're going to move to the right. And if we have a negative exponent, we're going to move to the left, okay? So what we're going to do is this. I start out with this number right here, and then I say, okay, this is a positive exponent. I'm going to move my decimal place 8 places to the right. And then anything that I move that has what I call a loop-de-doop, I'm going to have to fill it in with zeros. So 1, 2, 3, 4, 5, 6, 7, 8. The decimal point is now there. Not necessary to put it, but I'm going to fill in with 7 zeros, okay? I recommend that you don't put commas in there because somebody's going to put commas in the wrong place, but you definitely have to make sure that you don't leave the decimal point in between the 1 and the 4. And I see that all the time. I see students put 1.4 and then put 7 zeros, and that's not equivalent. It has to be without the decimal point, 4, 5, 6, 7. And that, I'm just going to put the commas here so that I can see that that's 140 million, okay? All right, the next one is very similar. We've got 4.5. We've got 10 to the 9th, so it's going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my new decimal point, and I'm going to have 8 zeros after the 5, okay? Now, if we go the opposite direction, a negative exponent says that we're going to move to the left. So 1.35, and I'm going to go 1, 2, 3. This decimal point is very important, so you have to have 0.00135. Now, a thing about the negative exponent is that you will always have one less zero than the exponent. So you see the exponent is 3. I have 2 zeros. You see the exponent over here is -8. I will have 7 zeros. If you have -5, you will have 4 zeros, okay? So 3.94, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. And so 1, 2, 3, 4, 5, 6, 7. I should have 7 zeros, okay? Now we're going to do some operations with multiplying and dividing numbers in scientific notation. So when we do these, one way to do them is you can actually write them out and then try to multiply them out and then put them back in scientific notation, but there is an easier way to do these. So you have to look at their answer. What are they asking you to put your answer in? And this is going to be in decimal notation. So sometimes you can't fit all these zeros on the calculator screen, so you're going to have to do it this way. You're going to take the numbers in front of the 10 and multiply those together. And then you're going to take the like bases, 10 to the 9th times 10 to the -5th, and learn what we did that very first part. By multiplying like bases, you write the base and you add the exponents. So 3.4 times 2 is 6.8 times, write the base, 9 plus -5 is +4. That's the answer in scientific notation, but they want the answer in decimal notation. So now you have to take 6.8 and move it 1, 2, 3, 4, and fill in with 3 zeros. So that's going to be your answer of 68,000, okay? So again, take 1.3 times 4, take 10 to the 7th times 10 to the -2. Group the like things together. 1.3 times 4 is 5.2 times, write the base, add 7 and -2, and you get 5. And then convert it to decimal notation. So 5.2, 1, 2, 3, 4, 5, and follow it with 4 zeros. So 520,000. We can do the same thing with division, except this time we're going to do the division of 8.4 divided by 4. That gives me 2.1. And then 10 to the -7 over 10 to the -4. Now, this is where you have to be careful. You will write the base, take the top exponent, and subtract the bottom exponent. And so that's going to change into -7 plus 4. So your final answer is 2.1 times 10 to the -3. That's the scientific solution, but they want it in decimal notation. So now you have to convert 2.1, 1, 2, 3, and make it 0.0021. Okay? All right, so this one, we are going to take our 6.9 and divide it by 3, and that gives me 2.3. We're going to take 10 to the negative 8 and divide it by 10 to the negative 2, which is 10, negative 8 minus negative 2. That becomes negative 8 plus 2, which is 10 to the negative 6. And so then they want it in decimal notation. And so we are going to move that decimal point 6 places to the left, which means we will have 5 zeros in front of the 2, 3. Okay? Now, the next one they're going to ask you to do these problems, they're going to ask you to do the operations, multiply them out, and then write them in scientific notation. So one way is that you can actually do the calculations, or you can change them into scientific notation up front. So it's the easier way to do it is probably to do the scientific notation. So 3 million is the same as 3 times 10, 1, 2, 3, 4, 5, 6, 10 to the 6th power. And 240,000 is the same as 2.4 times 10 to the 1, 2, 3, 4, 5 power. So now what we're going to do is we're going to multiply 3 times 2.4, and that gives me 7.2. And then we're going to take 10 to the 6 times 10 to the 5th by writing the base and adding those exponents. And that's all they want. They want it in scientific notation. So 7.2 times 10 to the 11th would be the correct answer. All right, if I change 0.0003, that's going to be 3 times 10 to the negative 4, and then I've got 1.9 times 10 to the negative 1, 2, 3, 4, 5, and so then I'm going to take 3 times 1.9, which gives me 5.7, and then I'm going to take 10 to the negative 4 times 10 to the negative 5 and write the base and add the exponents. So my final answer is 5.7 times 10 to the negative 9. Now this next one, you can actually do it on your calculator. I could actually probably insert that and put that in and do the division and then change my answer to scientific notation. So I'm going to show you another way. If I take 320,000 and I divide it by 8,000, I am going to get 40, okay? But they want that into scientific notation. So now I have to change 40 into blank times 10 to the blank. Since this number is greater than 10, I know my exponent is positive. My decimal point is right there, and I simply have to move it one place. So 4 times 10 to the 1. And then the last one, if I take 2,800,000 and divide it by 0.00007, I get a very big number. I get 40 billion. Okay? And so now I want to write that into scientific notation. So blank times 10 to the blank. Here's my decimal point. I'm going to move it so it's right after the 4, and then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the 10th power. And that finishes off 5.6.